Okay, hello. Again, this is Mrs. Todd, and this is the last lesson for the chemical reactions unit, apart from the elements and oxides worksheet that you should be working on at your own pace. If you happen to read the announcement, I did post a link to the textbook. So Nelson, the publisher, has allowed the textbooks to be available online. So Nelson happens to be June 25th. Your other classes, if they have Pearson textbooks, that publisher said only May 25th. I don't know what's going to happen with the schools. I don't know if the government keeps them closed longer than May 25th, if they'll change that. But for now, you should be able to get to your textbook for this class, certainly, and then for other classes as well. So after this video lesson, there will be a review worksheet posted and a practice test worksheet posted that obviously I would have given out if we were in class, as well as the accompanying solutions. So you can check that out, and again, email me if you have any questions. The next unit is called quantities in chemistry. So you'll want to get or find a good calculator that is able to do numbers like 6.02 times 10 to the power of 23. So I encourage you to figure out how to do the times 10 on your calculator. So looking at that, so the phone can do it, but it's a little bit awkward. So hopefully maybe you have a calculator or somebody in your family does at home. But that will be for the next unit. So I'll start posting videos for those. I'm going to say probably Wednesday after this lesson. I want to give you guys a chance to work on the review. So I'll switch my focus to my other classes. So I'll say Wednesday. I will, however, release or share on D2L all of the solutions to the homework for the next unit. So if you are a textbook reader, if you like to do that, then you can certainly start at the beginning of unit 3, quantities in chemistry, and we basically just go in order with the textbook. Essentially all of the homework is from the textbook. So if you prefer to do that or you like to do that, then again, no problem, go ahead. Okay. All right, so let's get on to writing net and total ionic equations. I forgot to do markup here, sorry. So this is actually a good review of what we did yesterday, because you can see here the example on the page is a double displacement reaction. So you can do this, you can write ionic equations for single displacement, which is not what we're going to focus on, but you can do it. But mostly it's for double displacement. Because what you're going to see is we're essentially going to show we're going to get rid of all of the ions that do not participate in the reaction. We're essentially going to show the formation of the solid. So if you look at the example there, silver nitrate plus sodium chloride, the L is kind of cut off, makes sodium nitrate and silver chloride. You can see that the silver and the chloride ions on the reactant side or the left side of the arrow are pink, and then on the right-hand side, they come together to make the solid. So they are actually the ions that participate in the reaction. The nitrate and the sodium remain aqueous on both sides of the arrow, which means that they are not changing. So if you remember from grade 9, one of the signs of a chemical change is that you need some sort of new substance formed. So if something is not changing, then that is not they do not participate in the reaction. So they are called spectator ions. So these spectator ions, it's really similar to a spectator of a sporting event. Comes to the event to watch, but they don't participate, right? So the spectator ions are present in the solution, but they are not involved in the chemical reaction. So when we write the net ionic equation, we're essentially going to get rid of them, and we're only going to show the formation of the solid, which is really, from a chemist's point of view, that's where the action is, right? So we can extract that solid, we could evaporate the water and purify it, sell it, do whatever. Okay, so the here, this point here, the sodium and these nitrate ions do not actually form a precipitate. They are known as the spectator ions. How can you tell? They are aqueous on both sides. Okay, so when you have a total ionic equation, so total implies all, then the total ionic equation is going to show the dissociated ions for everything. So everything that is soluble, we are going to dissociate, which basically means split apart. So when you have something like, let's say you have NaCl AQ, technically what that means is the sodium chloride has been dissolved in water. So really, if it's aqueous, that doesn't even exist. Really, it's going to exist as ions. And we've talked a little bit about this, the fact that ionic compounds will make electrolyte solutions. They will conduct electricity as a solution because the ions are mobilized and free. So technically, this doesn't even really exist like that. It would be, in a real sense, it would be found, sodium chloride, if it says aqueous, would be found as sodium ions and chloride ions. So when you write a total ionic equation, we're going to show all of the aqueous ionic compounds split apart, but we are not going to break apart the solid. So a solid is not the same as aqueous. Obviously, solid means, a chunk together, crisscross rule, ionic compound, commonly called a salt, all that kind of stuff. Okay, so let's take a look at it with the example. So we did, in the first here, we have silver nitrate, which is aqueous, sodium chloride, which is aqueous, sodium nitrate, which is aqueous. However, the silver chloride is a solid. So when you write the total ionic equation, we're going to split apart the aqueous substance. And when you have a total ionic equation, then really every single double displacement reaction, the reactants have to be aqueous. We talked about that the other day. So on the left-hand side will be all ions, and then there's only going to be one solid on the right-hand side. Okay, so when we do this, it is very important that you write AQ. Technically, if it's an ion, it should have a charge, but often students get stressed by this. So if you're taking grade 12 chemistry, the ion charge will be a little bit more important there. So I encourage you to try to think about the charge. So for silver, you could look at its charge on the periodic table, or you can uncross, right? So silver is +1. Nitrate is one of those ions on the back of the periodic table. Again, you could uncross, but really, for sure, you must write the aqueous. I would take marks off if you didn't, but then if you didn't write the charge, I wouldn't. However, next year, that's gonna become a bit of an issue, okay? So don't push out of your brain things you already know. We talked a lot about how to find the charge. We would have had the naming quizzes had we been at school, but so hopefully you didn't just forget all that, okay? So now I'm splitting apart everything that is aqueous, because technically, one more time, something like this does not exist like that. It is all ions. That's the definition of solubility. If it is going to be soluble according to that chart that we use, the guidelines, then it means that it's going to be if it's in water, then it's going to dissolve and fit in between the water particles, a cation and an anion. Okay, so then we have silver chloride, which is not an aqueous compound, so then you keep it together. You do not split it apart. So then when you go to do the net ionic equation, it shows only the ions involved in the chemical change, so the ones that make up the solid. So pick a light color and sort of so that you can still see what's underneath. Like don't go crazy when you cross stuff out. But if you look, so here we have nitrate, which is on the reactant side as aqueous, and here on the product side is aqueous. It has not changed. So when it's on one side and the other side hasn't changed, it crosses out. It did not participate in the reaction. Same thing with the sodium. Or you could look at the solid here. We have AgCl. It is made of silver and chloride ions. Or take a look, what's left over once you cross stuff out? We have silver and chloride makes silver chloride. Okay, let's do another example. So this question is much more like what you would have to do, say it was a test. Write the word equation, crisscross the reactants, figure out their formulas, then, displace and figure out which one's the solid. That's what this part is, the states. Then now we've just added total, net, and spectator ions. Okay, so I'm going to write, because again, this is a little bit awkward on the iPad, I'm going to write up here. So the word equation, which I encouraged you to do in the last lesson as well. So again, it doesn't matter which one you write first, barium sulfate and sodium sulfide. And certainly you could do the figuring out which one's going to be the solid right now if you wanted to. It actually really doesn't matter. Okay, so barium is in the second column. It's an alkali earth metal, it is 2+. Sulfur is 2-. Different from sulfate, which is on the back of the periodic table. And then sodium is an alkali metal, so its charge is +1. So if you write those out, if you struggle or you don't love naming, if you write them out, then it can help you figure out when you can like crisscross for the reactants, and then then you can re-crisscross when you do the products, and all of your work is shown. You don't need to show all that work if you are good at it, but if you're not, there's no reason for you to try to rush, like don't skip steps, okay? So barium and sulfur, they both have 2, which means they are going to cancel out. So you're left with BAS. It is aqueous. Again, you can use the solubility table. Sulfide is row 10, and then plus alkali earth ions, which is what barium is. It is soluble. Or you can remember that when you have a double displacement reaction, they have to be aqueous, so the reactants anyways. Okay, so now sodium is 1, but sulfate is 2, so when you crisscross, the 2 goes down there. Sodium is an alkali ion. It's row number 1 if you want. Anything with an alkali ion is going to be aqueous. So then, again, if you look at row number 1, it says any ion plus an alkali ion, which in this list there, lithium, sodium, okay, so sodium. So over here, that means that automatically sodium sulfide, you don't have to look up the sulfur again. You can kind of cut steps there if you want. You just looked it up. Oh, if everything with sodium is going to be aqueous, that means that has to be aqueous. So then you can sort of assume that the barium sulfate is going to be the solid, and then just double check with the table so that you are sure. Okay, so now when I go to crisscross, now I know barium is 2, sulfate is 2. So I don't have to look those up again. And then sodium is 1, sulfur is 2, the sulfide ion. So then again, when you crisscross, it goes down there. So anything plus an alkali ion is aqueous. That means that the sulfate will be the solid, but let's go check it out. Okay, so sulfate is row number 9. Sulfate plus, there it is, the third one in, calcium, strontium, barium is insoluble. Okay, so now we have our equation. It has states, but it does need to be balanced. So check it out. Oh, it is balanced, so we're good with that as well. Okay, so now the total ionic equation. So again, we're going to write out all aqueous. Oops. And split them apart. Again, really trying hard to use their states or their charges. So again, if you write them out up here, now you've got them when you go to do this. So barium is a 2 charge. Sulfide is a 2. And sodium is a 1, charge of 1. And then there's sulfate. Okay, so now we've hit a bit of a snag because it is not, there is a little bit of an issue here. So now we have a sodium. So it is tempting. People love to do this, but then that sort of implies that sodium is diatomic. And of course it is not. So do not do that. In fact, let me try this eraser here. I'm going to erase it. Okay. That is ugly. Don't do that. So, now what you do instead is write the 2 out front. So that is saying there are 2 sodium ions, which there is according to the little 2 down there. When you do iron clay for our new home, those things are elemental, like gases or liquids. They are never going to be in their ionic form. So even something like, I can't make a new sheet. Even something like O2, that's when it's a gas. If you have an oxygen ion, you're still not going to write the 2 down there. This is not the elemental form. Okay, so this is the elemental form. This is not in double displacement reactions. That's not what we're talking about. Okay, so try not to screw yourself up there. So you're always dealing with aqueous, which means ions, okay? Not the elemental form of these elements. So if there is a number down here, it's going to become the coefficient up there, okay? So I'm just gonna erase this, sorry. Okay, and then now we're going to not split apart the barium sulfate because it is the solid, and we're going to do the same thing. There are 2 sodium ions. I'm running out of room, sorry. And sulfur. Okay, if you balanced it correctly in the part B up here, then it should be balanced again. 1 barium, 1 barium. 1 sulfate, 1 sulfide, 1 sulfide, 2 sodiums, 2 sodiums, 1 sulfate, 1 sulfate. Okay, so it should be good. Now, when we do the net ionic equation, we are going to cross out spectators. Again, try not to go crazy so that, let's say I had to give you marks for both of these, then I could still see your total ionic equation. So really, you don't even really have to physically cross them out. You just look at the solid. So barium and sulfate are not going to cross out, but the sodium is aqueous on both sides, as well as the sulfide. So then the net ionic equation, we have barium ions, aqueous, sulfate ions, aqueous, make barium sulfate, which is a solid. And then if you have to write out the spectator ions, you can use their formula or you can use their words. It doesn't matter. Okay, so this is really just an extension of what we did with predicting double displacement. So if you're not sure how to figure out the solid, then I would just go back and check out either of those. Okay, so this homework, just wrote that wrong, is from the textbook. But again, I'm going to put practice test as well as a test review for you to work on. And then on Wednesday, I will post lessons for the next unit. I would rather post as many videos as possible all at once so you can kind of work at your own pace. But we have sketchy country internet, so sometimes it takes a while to upload the videos. So we'll have to see how that goes. Okay, so I will do my best, but check again on Wednesday. And in the meantime, work on this, the other lesson I posted, this lesson, and the review. As well, the elements and oxide worksheet goes with this unit, and then the CCA part 1 can be done